These are notes from Elham's Math 60 for Thursday, April the 30th, section 9.7, page 836. This is the last section for chapter 9. So tomorrow, Friday, May the 1st, we will have the chapter 9 exam. As the standard for now, it's open book, open notes, but no discussions. So I will email you the exam and you work out your answers and take pictures on your cell phone or scan them and email me back your answers by 11:59 p.m. tomorrow night. That would be Friday, May the 1st. As usual, try to send in a format that I can get on my computers. I can handle most of them, but some of you send in some format that my computer can't handle. So try to send it in a fashion like PDF, something which I think most platforms should be able to handle. Anyway, now we're doing exponential and logarithmic equations. The problems are equations at the start. There's an equal sign at the start of the problems. Something equals something, something equals something, and so on. Okay, for 21, 6 raised to the x minus 2 equals 36. That's a 36. The key thing is to write this as base 6, so that's a base 6. 36 we know is 6 squared. So now I have 6 to the x minus 2 equals 6 squared. The two bases are the same, so now I can just equate the exponents. X minus 2 equals 2, which means x equals 4. 27, 3 raised to the x squared plus 4x equals 1 over 81. A little bit harder, but I want to try to get the right side to be base 3. I recognize there's an 81 there, but it's on the bottom. So first I bring it up to the top and write it as 81 to the negative 1. And then I realize 81 is 3 to the 4th power, so I leave this stuff alone. 3 to the 4th power, this is 81, to the negative 1. And then I have a property that says if I have a power and then another power, I can multiply them. So I have 3 to the x squared plus 4x equals 3 to the negative 4. And now that I have the same base, 3 here and 3 here, I can equate the exponents. So x squared plus 4x equals negative 4. That's a quadratic equation, which means there's an x squared in it. So move the 4 over, make it x squared plus 4x plus 4 equals 0. This factors into x plus 2 squared equals 0. So I set this equal to 0, which gives me x equals negative 2. 31 has to be done in a calculator. 13 raised to the x minus 1 equals 2. The trick for this one is to log both sides. So in red I put log, log of the left side equals a log of the right side. The reason why you want to do that is you might recall once I have a log of something like this and there's an exponent, the exponent gets to come down in front. So x minus 1 log of 13 equals log of 2. Please notice this is in parentheses. It needs to be in parentheses. Then divide both sides by log 13. X minus 1 equals log 2 over log 13. Add 1 to both sides. X is equal to 1 plus log 2 over log 13. This is considered the exact answer. Then they want you to round to the nearest 4 digits of the right decimal point. So punch it in your machine, 1.2702. Again, experiment with your calculator. On some calculators you can just hit log 2 over log 13. Some of you have to hit it backwards. You might have to hit 2 log and get that answer and then divide it by 13 log. So just experiment with your calculator. And another quick word, it doesn't do it on my calculator, but some calculators, once you hit log, it automatically pops up with a left parenthesis. If, for instance, it says log, then you automatically get a left paren. For you folks, you'll have to close it with a right paren. So let's say if you were doing a log of 2, the log left parenthesis would already show up. Then you type 2 and then close it with the right parenthesis. And same thing for any other log that you see. 35, ignore the red for the moment. The original problem was 5 raised to the x minus 3 equals 3 raised to the 2x. So once again, you log both sides. And by logging both sides, these exponents get to come down in front. So now we have x minus 3 log 5 equals 2x log 3. And now I want to solve for x. So first I distribute here. So x log 5 minus 3 log 5 equals 2x log 3. Now I want to get everything on the left side that has x's, and the right hand side does not have an x. So this has an x, leave it alone. This has an x, so I'll subtract that over. So when I draw that arrow there, it means I'm subtracting 2x log 3 on both sides, as you can see here. This arrow means I'm adding 3 log 5 to both sides, so it shows up on the right hand side. So the left side has x's, the right side does not have x's. And the reason why you want to do that is because now you can factor an x as a common factor here. So x parentheses log 5 minus 2 log 3 equals 3 log 5, and just divide both sides by this mess. Now even though that looks messy, it's a number, I mean, it's no different than if I said x times 5, then you would just say, oh, divide by 5. Well, log 5 minus 2 log 3 is a number. It's not a nice number, but it's still a number nonetheless. So I divide both sides by it. So x is 3 log 5 over log 5 minus 2 log 3. And then again, punch it in your calculator, negative 8.2144. Quick word, when you're punching this in your calculator, you probably should do exactly what I have here. Put extra parentheses over here and over here to make sure that everything works out the right way. 39 is a little bit different. Ignore the red temporarily. E to the negative 0.2t equals 14.2. You might recall to get rid of an E, you want to do an ln. ln and E cancel each other. So in red, I sneak in the ln, and that way the ln and E can cancel out. So I just have negative 0.2t equals natural log of 14.2. Again, ln stands for natural log. Divide both sides by negative 0.2. So t is ln 14.2 divided by negative 0.2. Punch it in your calculator. Negative 13.2662, rounded to 4 digits to the right of the decimal point. 45, ignore the red. Again, the red is new stuff. What the original problem said was log of 7 minus x equals 2. So again, if you don't see any base next to the g, it's understood to be base 10, so I sneak in the 10 in red. Now I unscramble it. The base is 10, the exponent is 2. Come back in for the result. So 10 squared equals 7 minus x. 10 squared is 100. And subtract 7 on both sides, so 93 equals negative x. That's negative x, so to make it positive x, I just multiply both sides by negative 1. X is equal to negative 93. 51, again ignore the red. The original problem is like this. Ln of 3x plus 1 equals ln x plus 7. You might recall that what we did was to exponentiate both sides. So I put an e here and an e here. That knocks this out. That knocks that out. So it's just simply 3x plus 1 equals x plus 7. So subtract x on both sides. I want the x's on the left. And subtract 1 on both sides. 2x equals 6. So x is equal to 3. 55, log base 5 of 4x minus 1 plus log base 5 of x equals 1. So you might recall we have an addition here. So we put it together as a multiplication, the log of a single product. So there's a plus here. So log base 5 of 4x minus 1 times x equals 1. Now I unscramble it. Base is 5. Exponent is 1. Come back in for the result. And I multiply this out. So 4x squared minus x. So I have a quadratic equation because there's an x squared. So I subtract 5 on both sides. 0 equals 4x squared minus x minus 5. I factor. By the way, you could use a quadratic formula also. So 4x minus 5, x plus 1. So set that equal to 0. Set that equal to 0. This gives me x equals 5/4. This gives me x equals negative 1. However, that's not allowed. We mentioned briefly earlier that you were not allowed to take the log of a negative number. If I were to plug in a negative 1, you'd be taking the log of a negative. That's not allowed. 5/4 is okay, though. If I plug in 5/4, looks like I'm good. So the only real solution is x equals 5/4. 59, log base 3 of 4x minus log base 3 of 7 equals 2. There's a minus sign here. So you might recall I can take the log of a quotient, 4x divided by 7. Minus here means divide here. So log base 3 of 4x over 7 equals 2. Unscramble it. 3 raised to the second power. Remember, this is the base. You go across the equal sign for the exponent. Come back in for the result. So 3 squared equals 4x over 7. Multiply both sides by 7. 3 squared is 9. 9 times 7 is 63. 63 equals 4x. So x is equal to 63 over 4. 67, log of x plus 90 plus log x equals 3. Again, you don't see any base here or here, so it's understood to be base 10. And since it's a plus, the log of a something plus the log of something, so I put it together as a multiplication. Log of x plus 90 times x, and I sneak in the 10 here because it's understood to be base 10. Unscramble it. 10 to the third power, 10 cubed, is equal to this stuff. I distributed this as x squared plus 90x. Okay, 10 cubed is 1,000. Subtract 1,000 on both sides because I have a quadratic equation. X squared plus 90x minus 1,000. You can factor or use the quadratic formula. So I need two numbers whose product is 1,000. The difference is 90. That's 110. So x plus 100, x minus 10. This gives me x equals negative 100. But again, way back here, I don't want to take the log of a negative number, so that gets thrown out. 10 seems a viable answer because if I plug in 10, I only get positive quantities. So I just retain x equals 10. Okay, 69, 3 to the x minus 6 equals 81. I notice that 81 is a power of 3, just like it was over here. So I rewrite 81 as 3 to the 4th power. So right here I have the same base, 3 and 3, so I just equate the exponents. X minus 6 is equal to 4, that means x is equal to 10. 77, log of x minus 6 minus log of x minus 2 equals log of 5 over x. There's a minus sign here, so we know what that means. That means we're going to divide over here. So log of x minus 6 over x minus 2 equals log of 5 over x. Okay, and when I have this situation, I just set that equal to that. You can just get rid of the logs basically. Log of a equals log of b means that a and b have to be equal. So I just set x minus 6 over x minus 2 equal to 5 over x. Do the cross multiply rule, that times that equals that times that. X squared minus 6x equals 5x minus 10. It's a quadratic equation again, that means there's an x squared. So I'll subtract 5x on both sides, add 10 to both sides. It looks like this, x squared minus 11x plus 10 equals 0. Factor into x minus 1, x minus 10. This gives me x equals 1 or x equals 10. However, again, back in the original, I'm not allowed to plug in 1 either here or here because I'll be taking the log of a negative. If I plug in 10 here and here and here, it looks like I'm okay. I'm only taking the log of a positive. So I just leave x equals 10 as my only real solution. And finally for 85, e to the 3x equals 9. To get rid of an e, you take the natural log of both sides. So ln, ln. Remember, ln and e back to back, they cancel out. So I just have 3x. 3x equals ln 9. Divide by 3. X is natural log of 9 over 3. Punch it in your calculator. Again, some of you just literally type ln 9. Some of you have to hit 9 ln. Just experiment with your calculator. And again, if your calculator automatically gives you the left parenthesis, like it might just show ln paren, then after you hit 9, you have to close it with the right paren before you divide by 3. Anyway, 0.7324. Alright, so this is Malcolm's Math 60, Thursday, April the 30th, 9.7, the last section in Chapter 9. Tomorrow, Friday, May the 1st, will be the Chapter 9 exam. I'll email you just as before, open book, open notes, but no discussion, due by 11:59 p.m. Take pictures of your work on your cell phone and also take pictures of your homework if you want to get credit for the homework.